Hello, good evening. Welcome to this NPTEL live session for the deep course Deep Learning IIT Ropar. My name is Learning-IIT. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session we will discuss some practice problems on week 10 topics. In week 10, convolutional neural networks or CNN was taught. So we will discuss some questions on CNN, and if there are any questions or queries, you can ask me during this session. So we will start solving the practice problems, and you can write your answers in the chat. This is the first question. 48 filters of size 21 by 21 is applied to an image of size 327 by 327 with 0 padding and stride of 3. The image is an RGB image. The depth of the filter is same as the depth of the image. What will be the volume of the final image? So the image is of size 327 by 327 and it is an RGB image, so certainly there should be 3 channels in that image, and the filter that is applied is 21 by 21. 48 such filters are applied in the first convolutional layer. So what will be the volume of the final image? So the correct answer here is option B, 103 by 103 by 48. So the formula that needs to be followed to find out the output of a convolution layer is that if the original image is of dimension this w by h by d, this is the image, and if the kernel is f by f and there are k such filters applied, in that case the output image will have width w minus f plus 2 into p, and p is the padding and s is the stride. So w minus f plus 2p by s plus 1, and similarly h1 would also be the same. So if we plug in these values into w1, we will have, so w equals 327, f is here 21, padding is 0 and stride is 3 plus 1, so it should be 306 by 3 plus 1, which is 102 plus 1, that is 103. So width is 103 and height would also be 103, because width and height are same in this case, 327. So the final image would be of this shape 103 by 103 by 48. So this k here is 48, 48 filters are applied. So depth would always be the number of filters that has been applied. So this is the final output image, 103 by 103 by 48. Now question 2. Consider the following, this is kernel w and input x. So w is a one dimensional vector 1 3 4 2, and input x is also one dimensional, but you can consider these two as an image and a kernel or filter. And what output s is obtained by sliding the filter w over input x. So basically the input x and this kernel w goes through a convolution layer. Then what will be the output s? So in convolution, what we do is that we slide this filter W over this input. So first, as the W filter is of length 4, so we will consider the first 4 elements of the input X, and we have to do point-wise multiplication with the kernel. So the first element of S would be the sum of the point-wise multiplication of the kernel with the input. So the first element would be, so point-wise multiplication of the first 4 elements, this. So 2 plus 0 plus 20 plus 1. So 2 plus 0 plus 20 plus 1, so it's 24. So the first element is 24. Now we have to slide the filter to the next 4 elements. Basically slide this by 1 place. Now again do the point-wise multiplication of these pairs and then take the sum of those. So now the point-wise multiplication would be 0 plus 3 into 5 15 plus 4 into 1 4 plus 2 into 3 6 3 is 6. So it would give us 26. Sorry, this would give us 25. 25 is the second element. Now we have to slide W by 1 place to the right again, and then again do this point-wise multiplication and take the sum. So first pair is 1 and 5, so 1 into 5 is 5, 3 into 1 is 3, 4 into 3 is 12, 2 into 4 is 8. So this summation would be 8 plus 12 20, 28. And now finally the last slide would be here. So the last 4 elements of X would be multiplied with the filter element wise, and then we have to take the sum. So 1 into 1 is 1, 3 into 3 is 9, 4 into 4 is 16, 2 into 8 is also 16. So it would be 10 plus 32 42. So these are the 4 elements of the output S that we will obtain by convolving the filter W over the input X. So we just have to slide the filter W over X and take the point-wise multiplication and take the sum for every element of the output S. So correct option is B, 24, 25, 28, 42. Now question 3. What is the output of the following convolution with stride equals to 1 and padding equals to 0? So the input is this 3 by 3 matrix and kernel is this 2 by 2 matrix. So the question is that you have to compute the output of the following convolution with this input and kernel matrices. So for this question, as this kernel is 2 by 2 and the input matrix is 3 by 3, so first we have to consider this 2 by 2 sub matrix of this input matrix. So these are the 4 elements 1 5 6 2. We have to pointwise multiply this with the kernel, so this, and then pointwise multiply with the kernel, which is 1 0 0 1, and take the sum. So if we do this pointwise multiplication, we will have 1 0 0 2. Then we have to take the sum of this all 4 elements of this pointwise multiplication matrix. So this is 3. Then we have to stride is 1, so we have to move this window to the next 2 by 2 matrix here in this input, and then again do the matrix pointwise multiplication with the kernel, and then take the sum. So the new window is 5 9 2 7. So the pointwise multiplication would be 9 0 0 7. So the sum would be 12 for this matrix. So now we slide this window to the next 2 by 2 matrix 9 4 7 11, 9 4 7 11, and the pointwise multiplication with the kernel matrix would give us 9 and 11 0 0. So the sum for this matrix would be 20. Now the next 2 by 2 matrix is this one 6 2 12 10. So there will be 6 2 12 10. So pointwise multiplication would give us 6 and 10 in diagonal elements, and 0 and 0. So the total would be 16. So similarly you have to do the same calculations for the next 2 by 2 matrix, which contains 2 7 10 3, and then the last 2 by 2 matrix or window which contains 7 11 3 8. So these are the elements that you will get. So this is the answer. So the first, this 2 by 2 matrix and the kernel, pointwise multiplication of these two matrices and sum gives us 3, and then when we slide this to the next 2 by 2 matrix, now the pointwise multiplication and the sum gives us 12, similarly then 20, and then for the next row this 6 to 12 10. For this 2 by 2 matrix, the pointwise multiplication and sum will give us 16. Then for this sub matrix 2 7 10 3, pointwise multiplication with the kernel and the sum would give us 5, and finally for the last 2 by 2 matrix, pointwise multiplication with the kernel and the sum would give us 15. So this is how you have to compute every entry in the output matrix. So as padding is 0, so no padding is used, and stride is 1, that's why we are sliding this 2 by 2 window by 1 plus. So this was the first window, then we slide it by 1 plus to the right, this was the second window, then we slide it to the right once more, this was the third window, because this stride is 1 here. Moving on to question 4. What will be the output of the following matrix after average pooling operation with kernel size 2 by 2 and stride equals to 1? So this is the input matrix, and we want to do average pooling with kernel size 2 by 2 and stride equals to 2. So for this average pooling operation, the kernel size is 2 by 2. So we have to first consider this first 2 by 2 window in this input matrix and take the average for this window. So this 2 by 2 window, we have to take the average of this window. So the elements are 5, 7, 3, 1. So the average would be 5 plus 7 plus 3 plus 1 divided by 4. So that would give us 12 plus so it's 12 plus 4, which is 16 by 4. So first element would be 4. So in the output matrix, first element would be 4. Then the stride is 2. So the next 2 by 2 matrix would be this one. Now I have to take the average of this 2 by 2 matrix. So 9, 8, 2, 3. So 9 plus 8 plus 2 plus 3. So that would be 17 plus 5, which is 22. So it would be 5.5. So the next element in the output matrix would be 5.5. Now after this stride is 2. So the next 2 by 2 matrix would be this one. So 4, 9, 8, 3. 4 plus 9 plus 8 plus 3. So that gives us 13 plus 13. So it's 13 plus 8 is 21. 21 plus 3 is 24. So it's 6. Now the last 2 by 2 matrix is this one, which is 5 plus 7 plus 8 plus 6. So the total would be 12 plus 20, 26. So 26 is 6.5. So this is the output matrix: 4, 5.5, 6, 6.5. Yes, this is the output. Now question 5. This question is again on convolution operation with stride 2 and padding 0, and this is the input matrix and this is the kernel. So what will be the output of this convolution operation with this input and kernel? So this is 4 by 4 input matrix, and it is a 2 by 2 kernel matrix with stride 2 and padding 0. So similar to the convolution operation that we did in one of the previous questions. So the kernel is of size 2 by 2. So first we have to consider the first 2 by 2 submatrix of the input matrix. So this is the first 2 by 2 submatrix, and we have to do pointwise multiplication with the kernel and take the sum to get the first element in the output matrix. So if this is the output matrix S, so the first element would be the pointwise multiplication of this submatrix and the kernel, and then the sum. So if we do the pointwise multiplication and the sum, then it would be 10 plus 15 plus 2, which is 27. Now the stride is 2, so the next 2 by 2 window will be this one, and then again pointwise multiplication with the kernel followed by summation. So it would be 9 plus 14 plus 11, which is 24. Now the next 2 by 2 window is this one, again pointwise multiplication with the kernel followed by summation will give us 21 plus 10. So this one would be 34. 9 plus 11 plus 9, 20, 34. And so the third element would be 12 plus 10 plus 9, which is 21 plus 10, which is 31. And then the next 2 by 2 window, also the last 2 by 2 window would be this one. So then pointwise multiplication with the kernel and summation would give us 3 plus 18 plus 13, which is 16 plus 18, 34. So this is the output matrix that we will get by this convolution: 27, 34, 31, 34. As the kernel looks like this, that the first element, second element and the fourth element are 1 and the third element is 0. So simply we have to take the sum of these three to get the first element, then take the sum of these three to get the second element here. Similarly, take the sum of these three to get the third element, and take the sum of these three to get the final fourth element. Now question 6. Which of the following 3 by 3 kernels works best for the edge detection task in an image? The 4 matrices are given in the options. So the correct answer is option C. So in this kernel, this kernel will give 0 when all the neighboring pixels are the same, and non-zero when the neighbors of a pixel are not the same. So that is in the edges. So this is -8, and all the other 8 neighboring elements are 1. So that's why it can detect edges much better than the other kernels. So because in case of edges, the neighboring points would have different activations or values than the centering the point in the center. So that's why this kernel would be able to detect edges in an image. So this is also taught in the video lectures. Now question 7. What is the main innovation proposed in ResNet architecture? There are 4 options: use of 1 by 1 convolutions, residual connections, use of different sized filters at a single layer, and option D is increasing the width of the network. So the correct answer is option B, residual connections. So in ResNet architecture, the input might go through multiple convolution or fully connected layers or max pool layers, but we also have a skip connection. This skip connection through which the input is connected to the output here. So this X is added to the output here, back to the output. So all these so we can literally skip all these layers and add this X to the output, so that it can easily model the identity function, which generally improves the performance of the networks. So that is a residual connection, and it is the main innovation proposed in the ResNet architecture. Now question 8. What is the purpose of using a stride larger than 1 in convolutional neural networks? There are 4 options: to increase the number of convolution operations in a layer, to reduce the size of the output feature map, to increase the number of trainable parameters, to increase the receptive field of the convolutional layers. So the correct answer here is to reduce the size of the output feature map. So if we take strides larger than 1, for example 2, then the width and height values of the input image is halved in the next layer. So that gives us lesser number of activation units in the next layer, and it would also reduce the number of parameters in the neural network. So the main purpose is to reduce the size of the output feature map. Now question 9. Consider a convolution operation with an input image of size 256 cross 3 and 63 filters of size 11 by 11 by 3 using a stride of 4 and padding of 2. What is the depth, which is h in w cross b cross h of the output image? So what is the depth of the output image? So the depth of the output image depends only on the number of filters used in that convolution layer, convolution operation. So the depth of the width and height of the output image depend on many other values like the input image size, the filter size, padding, stride, etc. But the depth only depends on number of filters used. So there are 63 filters that are used for this convolution operation. So the depth of the output image should always be 63, irrespective of the size of the image, size of the filter, stride or padding. So the depth is 63 as 63 filters are used. So these were the questions that I wanted to discuss in this live sessions. Now if there are any questions or queries regarding any of the questions discussed today or any other topics covered in this week's lectures, you can ask me now. So if there are no other questions or queries, then we can end this live session now. Thank you everyone for joining. We will meet again next week.